Welcome everyone. Today we're examining the occupational health risks associated with beryllium and its compounds. We will cover the properties of beryllium, the industries where it is used, and the main health risk studies, and the regulatory requirements designed to protect workers. Our focus is to understand how exposure can occur and what measures are critical for prevention. This is just a disclaimer. Please read through it at your own peril. Introduction. What is beryllium? Beryllium is a unique metal prized for being both extremely strong and lightweight. It's grey in color, brittle in nature, and notably it's stronger than steel, yet much lighter than aluminium. Beryllium withstands high temperature and does not conduct magnetism, making it ideal for a range of industries applications. It forms compounds such as beryllium oxide and beryllium sulfate, which are used in various processes. In industry, beryllium is found in three main forms: as a pure metal, as an oxide, and is most often combined with copper. The atomic number of beryllium is 4, and its properties have made it highly valuable, but also hazardous, as we will discuss. Beryllium's unique characteristics leads it to use in a broad spectrum of industries. In aerospace and defense, it's essential for manufacturing aircraft, missile components, and satellites due to the strength to weight ratio. The electronics industry relies on beryllium for X-ray windows and computer parts. In the nuclear sector, beryllium serves as a reflector and moderator in reactors. The automotive industry uses it in high-performance parts, while the telecommunications benefits from its use in electronic connectors. Medicinal manufacturers incorporate beryllium into dental alloys and surgical instruments. It is also used as a metal additive in ceramics and metallurgy, and in the energy sector, particularly for equipment used in oil and gas extraction. This widespread use increases the potential for occupational exposure. Risk of exposure. Despite its usefulness, beryllium is highly toxic. It poses significant risks in both the skin irritant and when inhaled as a dust or fumes. Skin contact can result in dermatitis, while inhalation can lead to severe lung diseases such as pneumonitis and chronic pulmonary disease. Alarmingly, even low levels of exposure can sensitize the body, resulting in severe allergic reactions and chronic illnesses. The first sign of serious exposure typically involve respiratory symptoms such as difficulty breathing, chest pain, or shortness of breath. Employees in smelting, machining, and recycling industries face the greatest risk, and it is important to note that adverse health effects have occurred even when exposure levels remain below the recommended workplace limits. This underscores the need for strict control measures. The primary disease associated with beryllium exposure is chronic beryllium disease, or CBD, also known as berylliosis. CBD is a chronic immune-mediated lung disease where inhaled beryllium triggers an ongoing inflammatory response. This leads to the formation of granulomas, which are small areas of inflamed tissues and scarring in the lungs. Common symptoms include shortness of breath, persistent cough, fatigue, chest pain. Weight loss diagnosis is complex and often involves blood tests, imaging such as X-rays or CT scans, and sometimes lung biopsy. Treatment usually requires corticosteroids or immunosuppressive drugs, but most crucial intervention is removing the worker from further exposure to beryllium. In addition to CBD, beryllium exposure can cause several other serious health conditions. Acute beryllium disease, also known as pneumonitis, typically results in high-level, short-term exposure leading to a sudden lung inflammation. Symptoms can include coughing, chest pain, shortness of breath, and fever. If exposure ceases promptly, this condition may be reversible, but if not, it can progress to respiratory failure. Beryllium can also sensitize the immune system, meaning that even a small future exposure may trigger severe reactions. Skin contact can cause ulcers, rashes, or wart-like lesions, particularly if the skin is already broken. Importantly, beryllium and its compounds are classified as IARC Group 1 carcinogens, meaning they are proven to cause cancer in humans. This wide range of possible health effects highlights the importance of robust safety measures. Okay, we're going to have a look at a case study of acute beryllium disease called ABD. If we look at historical examples between 1940 and the 1980s, metal production workers exposed to high levels of airborne soluble beryllium frequently developed acute respiratory illnesses. Symptoms such as shortness of breath, chest pain, and non-productive coughs often appeared within weeks of exposure. In primary instances, these symptoms recurred with subsequent exposures. These cases clearly demonstrate the risks posed by airborne beryllium, especially when proper controls are lacking or not enforced. In another case, a 47-year-old worker from an electronics recycling industry with no prior history of lung disease was diagnosed with chronic beryllium disease after years of low-level exposure. The worker initially presented with fatigue and shortness of breath. This case illustrates how even chronic, low-level exposure can eventually lead to severe disease, particularly if individuals who become sensitized. Sensitization is an immune response that can develop silently and only manifest clinically when the disease is already established. Secondary exposure is also a concern. There have been documented cases where individuals not directly working with beryllium developed CBD after being exposed to contaminated clothing or equipment brought home by their family members. This highlights the importance of not just workplace controls, but also policies preventing beryllium dust from leaving the work site. To protect workers, a combination of engineering controls, personal protective equipment, and safe work practices is essential. Engineering controls include local exhaust ventilation and fully enclosed processes for minimizing airborne dust. Employees must use appropriate PPE, such as approved respirators, coveralls, gloves, and eye protection. Work practices should focus on minimizing dust generation, for example, by using wet methods and prohibiting eating, drinking, or smoking in contaminated areas. Cleaning should be done with HEPA-filtered vacuum equipment, and regular hand washing and changing into clean clothing before leaving the worksite should be mandatory. Beyond basic controls, additional safety measures are crucial. Regular medical surveillance, including lung function tests and sensitization screening, helps with early detection of disease. Comprehensive training ensures all workers understand the hazards and know how to handle emergencies. Continuous air monitoring is necessary to confirm that exposure limits are not exceeded. Warning signs are restricted, and access may be clearly posted in all hazardous areas. It is also important to recognize that CBD can be misdiagnosed, often as sarcoidosis. So advanced diagnostic tests like beryllium, lymphocyte proliferation test, and lung biopsies may be required to confirm the diagnosis. In South Africa, the management of beryllium is governed by several regulations. The Hazardous Chemical Agents Regulations of 2021 require employers to identify the control risks, monitor exposure, and ensure workers use appropriate PPE. The Mine Health and Safety Act 29 of 1996 imposes similar obligations in the mining industry, including mandatory exposure, monitoring, and reporting. These regulations are designed to keep workplace exposures below recognized occupational exposure limits, protecting both employees and the broader community. Specifically, the Mine Health and Safety Act requires mining employees to submit regular reports on personal exposure, monitoring to the development of mineral resources, with assessments conducted by qualified occupational hygienists. Medical surveillance, including tests like the BELPT, must be completed with informed consent, ensuring that workers are aware of their health status and any potential risks. Early identification of sensitization or disease allows for timely intervention and prevention of progression. Wherever feasible, hazardous substances like beryllium should be substituted with safer alternatives to further reduce risk. The ILO provides technical guidance and encourages all organizations to adhere to the highest international exposure standards. The ultimate goal is to prevent occupational diseases before it occurs through evidence-based controls and culture safety. In summary, while beryllium is a valuable industrial material, it carries significant health hazards. Exposure can lead to serious lung diseases, cancer, and debilitating skin conditions. Protecting workers requires strict adherence to safety protocols and regulatory requirements. By implementing engineering controls, using proper PPE, conducting regular medical surveillance, and fostering a culture of safety, we can minimize the risk and ensure a safe work environment for all. If you've enjoyed this, please leave a like, subscribe, and if you have any questions, leave them down in the comments. Keep safe out there.